In this video, we're going to continue to work with our 6 trigonometric ratios, the 3 ratios, sine, cosine, and tangent, and the reciprocals, cosecant, secant, and cotangent. So for these scenarios, what we're going to look at today, what we want to focus on is notice that they tell me that they have triangle ABC where C is a right angle. Okay? For most of these, then, what we want to do is draw a sketch of a right triangle, because this will kind of give me some guidance, and I know C has to be the right angle, so I'm just going to call the other vertices A and B. Now, because I know A, B, and C here, I know that the sides across from each of those vertices are the lowercase representation of each of those letters. So, for instance, I know that this side over here is 9, and I know that the side across from angle B is side B, which is 12. Once I have this organized, I can now start to look at finding what they want me to in this problem, which is what's the sine of A. So to find the sine of A, I know that sine is defined as opposite over hypotenuse. Opposite of angle A is 9. But the problem is here, I don't know the hypotenuse. I then got to go to the Pythagorean theorem, and I'm going to call this side C. And I know that C squared is equal to 9 squared plus 12 squared, according to the Pythagorean theorem. Now, I'm going to do some of these calculations on my calculator. Let me know if you need help with the calculator, but I think you guys are going to be fine. If I take 9 squared plus 12 squared, I get 225. So C squared is 225. And I know, therefore, C would be 15. I take that value, substitute it in for the hypotenuse. And the last step is now I've got to take this 9/15 and simplify it. So the sine of A would be 3 over 5. Okay? Each scenario, I like to start with a new triangle. So again, I'm just sketching triangle ABC. All right? For this problem, they want me to find the cosine of A. All right, I'm going to put in what I know. I know side B is 22. I know side C, which is the hypotenuse, is 13 square root of 5. The cosine of A is defined as adjacent over hypotenuse. So I'm ready to go here. I've got the adjacent side, 22. I've got the hypotenuse, 13 radical 5. So I'm going to go ahead and move this over just in case I need to simplify. Cosine of A is going to be 22 over 13 radical 5. Now, I need to take this a little bit further, though, and rationalize it. And remember, all you have to do with rationalizing is multiply the top and the bottom by the radical. So this is going to become 22 radical 5 over 13 times the square root of 25, which would be 13 times 5, and 13 times 5 is 65. 22 and 65, I can't cancel. There's my final answer. All right, so the tangent of A, let's see here. Sketch a triangle and identify the given. And again, I can't emphasize this enough. I'm just making a general triangle. They tell me that side B is 3 radical 7. They tell me that side C is 12. Now, in order to find the tangent of A, I need to know this opposite side. Tangent is opposite over adjacent. So I'm going to use Pythagorean theorem here to find side A in this case, which would be 12 squared is equal to A squared plus 3 radical 7 squared. Now I'm going to show you a little trick. If you take that 3 and square it, which would be 9, and multiply that times the 7 that's already inside, I move that 3 inside the radical. So this would be the square root of 63 squared. It's a little bit easier to work with because now I've got 144 equals A squared plus 63. If you square a square root, the square root disappears. So if I take 144 and subtract 63, I get 81 is a squared, so I know a would be 9. Now I'm ready to find the tangent of a. The tangent of a would be opposite 9 over hypotenuse 3 radical 7. I'm going to go ahead and rationalize, which would be 9 radical 7 over 21. And I know that 9 and 21 can simplify. They're both divisible by 3, so this would be 3 radical 7 over 7. Yes, I'm expected to always simplify and rationalize my fractions. So now let's look at some more. Even though they changed to one of the other trig functions, one of the reciprocals here, I still set it up and do it most of the way the same way. So I've got triangle ABC, where C is still the right angle. They tell me that side C is 20. They tell me that side A is 16. And they want me to find the cosecant of A. Now, cosecant, I've got to remember, cosecant is the reciprocal of sine. So that would be 1 over the sine. Okay? I know that sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. I've got the information that I need to be able to figure this out. The cosecant of A would be hypotenuse over opposite. I simplify that fraction. Both are divisible by 4. And the cosecant of A would be 5/4. All right. This one says find the secant of A. So I've got my right triangle here. Call it ABC. They tell me that C is 15 and B is 12. And they want me to find the secant of A. Now I know that secant is 1 over the cosine. I know that cosine is adjacent over hypotenuse. So secant would be hypotenuse over adjacent. I've got both of the pieces that I need. I'm ready to find the secant. The secant of A would be 15, hypotenuse over adjacent, 12. Both are divisible by 3, so this would simplify to 5 over 4. Remember, if there's just a piece that you don't know, Pythagorean theorem is how you find that missing piece. All right, so the last one here, what if I want you to find the cotangent? All right. And it's kind of nice because I'm looking at it and I know that I'm going to have the pieces that I need because A was 8 and B was 6. I don't need the hypotenuse to find the tangent or the cotangent. Remember, cotangent is the reciprocal of tangent. Okay? So the cotangent of A, instead of it being the tangent of A would be opposite over adjacent. This will be adjacent over opposite. And I simplify the fraction to 3/4. Let me know if you guys have any questions. Good luck.